So we're on problem number 1 on the California Standard Tests problems for Algebra 2. And so the theory being is if you are able to do all, or at least understand all 80 of these questions, I think you have a pretty good understanding of Algebra 2, at least from the perspective of California. See, problem number 1. What is the complete solution to the equation the absolute value of 3 minus 6x is equal to 15? So let's think about it. 3 minus 6x could clearly be 15 because the absolute value of 15 is 15. So we could say that 3 minus 6x could be equal to 15. But 3 minus 6x could also be equal to minus 15, right? Because the absolute value of minus 15 is also 15. So let's write that down. So, or 3 minus 6x is equal to minus 15. Right? If this was equal to minus 15, you take the absolute value, you'd get positive 15. So either of these could be true. So let's solve for x. Subtract 3 from both sides, you get minus 6x is equal to 12. Divide both sides by minus 6, you get x is equal to minus 2. And so here, if we subtract 3 from both sides, you get minus 6x is equal to minus 15 minus 3. That's minus 18. Divide both sides by minus 6, you get x is equal to positive 3, right? Negative divided by negative, so x is equal to 3. So x could be minus 2 or 3, and that's choice B. Choice B. Problem 2. Let me switch colors to make things interesting. And there's a similar type of problem. What are the possible values of x in, see, the absolute value of 12 minus 4x is equal to 2. Same logic. 12 minus 4x could be 2, right? The absolute value of 2 is 2. So you get 12 minus 4x is equal to 2. Or 12 minus 4x could be minus 2, right? Because the absolute value of minus 2 is 2. So then you get 12 minus 4x could be equal to minus 2, right? So this is an or proposition. So let's see. Subtract 12 from both sides. You get minus 4x. 2 minus 12 is minus 10. Then you get x. Divide both sides by minus 4 is minus 10 over minus 4. Then the negatives cancel out. And that's equal to 5 halves. Or 2.5. Or 2.5. And the only reason why I wrote 2.5 is I was looking at the choices and they have everything as decimals. So let's look at the other possibility. Subtract 12 from both sides, you get minus 4x is equal to minus 2 minus 12 is minus 14. X is equal to minus 14 over minus 4. Negatives cancel out, which is equal to 7 halves, which is equal to 3.5, which is equal to 3.5. So x could be 2.5 or 3.5, and that is choice D. Problem 3. I'll switch to maybe green. Problem 3. For a wedding, Sharada bought several dozen of roses and several dozen carnations. The roses cost $15 per dozen, so roses are $15 per dozen. The carnations cost $8 per dozen, so the carnations are $8 per dozen. Sharada bought a total of 17 dozen flowers and paid a total of $192. How many roses did she buy? All right, so let's set some variables. Let R equal dozens of roses. Dozens of roses. I hope you can read my handwriting. Dozens of roses. And let C equal to dozens of carnations. All right, so they say that she bought a total of 17 dozen flowers. So the dozens of roses she bought, the dozens of roses plus the dozens of carnations she bought must be equal to 17 because she bought a total of 17 dozens. It also tells us that she spent $192. So how do we figure out how much money she spent? So if she bought R dozens of roses, how much did she spend on roses? Well, each dozen of roses is $15, so she spent 15 times the number of dozens. That's how much she spent on roses. How much did she spend on carnations? Well, she bought C dozens of carnations. Each dozen was $8. She spent $8 on carnations. So her total amount of money she spent was the amount she spent on roses plus the amount she spent on carnations, and that is equal to 192. Now we have two linear equations and two unknowns. We can just solve them. Listen, we want to solve for the number of roses. That was the question. So let's try to cancel out. Let's try to cancel out the number of carnations. So if we multiply this top equation by -8, we'll get a -8c. That'll cancel out with that. So let's do that. So let's multiply that top equation by -8. You get -8r minus 8c. What's -8 times 17? Let's see, 17, I'll do it in the corner here. 17 times 8. 7 times 8 is 56. 1 times 8 is 13, plus 5 is 1. 1 times, oh, my brain was getting ahead of me. 1 times 8 is 8, plus 5 is 13. Sorry. It's equal to 136. Oh, and we multiplied by -8, so we put a negative there. And now we can add these two equations. 15 minus 8, 7r. 8c minus 8c is 0, and that was the whole point behind multiplying this top equation by -8, is equal to 192 minus 36. Let's see, do a little borrowing, or regrouping they call it now. That's 12. That's 8, so it equals 56. 7r is equal to 56, so r is equal to 8. So Shareda bought 8 dozens of roses, and that is choice C. Choice C. Problem 4. Problem 4. What is the solution to the system of equations shown below? And there's 3 of them with 3 variables. Always the hairiest problem. Let's see. We have 2x minus y plus 3z is equal to 8. We have x minus 6y minus z is equal to 0. And then you get minus 6x plus 3y minus 9z is equal to 24. Now there's a bunch of ways to solve these. You could use matrices and inverses of matrices and Gauss-Jordan elimination, or you can just kind of use your traditional, multiplying equations by each other and adding them so that you can kind of constrain them or take out variables. And we'll do the last one because I don't want to introduce any other kind of matrix manipulation here. So what I want to do is let's use this equation with both of these and try to cancel out the x's, right? And the best way to do that, well, let's think of how we could do that. Well, one thing I like to do, just to simplify it, is to get all of the equations in what I kind of consider, lowest integer form. I know that's not a formal term, but you look at all of the terms in this equation. They're all divisible by 3, right? So let's divide all of them by 3. So this last equation would become, if you divide everything by 3, you'd get minus 2x plus y minus 3z is equal to 8. So let's cancel that out. I just divided it by 3. It's the same thing. Remember, whatever you do to one side of an equation, you could do to the other side of the equation. Anyway, so let's use this equation and then this equation and this equation to get two equations with just y's and z's. So essentially, we want to cancel out the x's. So to cancel out the x's with this one and this one, we can just add them, right? Because 2x plus minus 2x, that's going to cancel out the x's. So we can just do that. And then when we do it with this equation, we could multiply this equation times minus 2 first, and it'll cancel out the x's there. So let's do it. 2x, so let's just write it, and I'll write it in green. So if I add this equation to this equation, 2x minus 2x is 0x plus, minus y plus y, that's 0y. These are all 0, but I'm just writing them down to show that we're done. And then plus 3z, well, they all cancel out. Plus 0z. So it actually, these is equal to 8 plus 8 is equal to 16. So you get 0 is equal to 16, which makes no sense. And actually, so there's actually no solution here. And if you wanted to think about visually what's happening is, each of these equations represent a plane in 3 dimensions. And the only way you get no solution or no intersection between this equation and this equation or this equation, which is essentially the same equation, the only reason why you can't get the intersection between them is that they must be parallel equations. You could get an infinite number of of solutions if they were actually the same plane. But these are parallel planes, so they'll never intersect. So we saw, and it kind of makes sense because this part, well, I'm not going to go into the details. We're just focused on solving problems right now. But it's fair enough to say that when you add this equation to this equation to cancel out the x's, everything else cancels out, and you get a nonsensical statement 0 equals 16, so there's no solution, and that's choice C. And those are parallel planes in 3 dimensions. Problem 5. A restaurant manager bought 20 packages of bagels. Some packages contain 6 bagels each, and the rest contain 12 bagels each. There were 168 bagels in all. How many packages of 12 bagels did the manager buy? So let's say, so the total number, so he bought some packages of 6. So the packages of 6 plus the packages of 12, that's just my random notation that I invented. He bought a total of 20 packages, so that equals 20. And then he bought a total of 168 bagels in all. So how many bagels did he get from the 6 packs? Well, each of them had 6 bagels, right? So he got 6 times the number of packs. So he got 6 times this. This is the number of bagels he got from the 6 packs. And then he got this time. This is the number of bagels he got from the 12 packs, right? The number of packs times 12. And then that is equal to 168. 2 equations, 2 unknowns. They're linear equations. We should be able to solve this. So let's multiply. So they say they want to know how many packages of the 12 bagels did he buy. So they want to know what P sub 12 or whatever you want to call that is. So if we want to do that, let's cancel out the P6's. So if we multiply that top equation by minus 6, you get minus 6 times the 6 packs minus 6 times the 12 packs, just multiplying this top thing by minus 6, is equal to minus 120. Now we can add the 2 equations. These cancel out. That was the whole point. 12 times the 12 packs minus 6 times the 12 packs, that's equal to 6 times the 12 packs. It's equal to 168 minus 120 is 48. And so we get, let's see, the 12 packs, there were 48 divided by 6 is 8. So there were 8 12 packs. The manager bought 8 12 packs. That is choice B. And I'll see you in the next video because I'm all out of time.